70 feet beneath the Atlantic Ocean, in complete darkness, a machine the size of a football field is crawling forward, inch by inch, blind. The pilot can't see where he's going. He's navigating by numbers on a screen, trusting lasers and sensors, hoping the ground ahead doesn't collapse, hoping the ocean doesn't break through, hoping he doesn't drift even a few feet off course. Above him, aircraft carriers pass. Below him, nothing but crushing pressure and ancient sediment. One mistake, and the Atlantic wins. He's not searching for treasure. He's not laying cable. He's building a tunnel that will carry 200,000 vehicles a day. A tunnel that connects the world's largest naval base to the mainland. A tunnel that, if it fails during construction, could flood in seconds and become an underwater grave. This is Hampton Roads, Virginia, where a traffic jam became a national security threat, where the only solution was to drill through the ocean floor, while the world kept spinning. Above, this is the story of a $3.8 billion gamble against nature itself. Hampton Roads isn't just another coastal city. It's a strategic fortress, Naval Station Norfolk. The Atlantic Fleet, carriers, destroyers, submarines, the backbone of American sea power, all concentrated in one place, and there's only one way in. The original Hampton Roads Bridge-Tunnel opened in 1957, 2 lanes in each direction. A marvel of engineering for its time, tunnels burrowed beneath the shipping channel, connected by bridges and artificial islands rising from the bay. But the architects of 1957 couldn't imagine the world of 2020. Today, over 100,000 vehicles crawl across this corridor every single day. Morning commutes that should take 20 minutes stretch to 2 hours. Accidents shut down entire directions of traffic. A single breakdown can strand thousands. For naval personnel, it's worse than inconvenience. Imagine being a pilot on an aircraft carrier about to deploy. Your ship leaves in 2 hours. You're stuck in gridlock, watching the clock tick down, knowing your crew can't leave without you. Or picture an emergency at the base, equipment failures, security threats, medical crises, and the ambulances can't get through. The bridge tunnel wasn't just congested. It was a single point of failure for the most powerful naval force on the planet. A vulnerability enemies could exploit without firing a shot. Just wait for the traffic to do the work. Something had to change. In 2016, the decision was made: expand the Hampton Roads Bridge-Tunnel. Add 2 new lanes in each direction. Double the capacity. Eliminate the bottleneck. Cost: $3.8 billion. Timeline: 5 years. Complexity: off the charts. Because you can't just build a bridge when aircraft carriers need to pass underneath. The new design would mirror the old. Twin tunnels bored beneath the shipping channel, connected by bridges and expanded islands. But this time, the tunnels would be deeper, longer, more complex, and they'd have to be built while traffic continued flowing on the existing structure just yards away. No stopping, no detours. The naval base couldn't close. The economy couldn't pause. It would require precision engineering on a scale rarely attempted. Massive tunnel boring machines, each the length of a football field. Underwater excavation in zero visibility. Concrete poured in chambers where the pressure could crush a human body. But the most dangerous part? The tunnel itself. 4 miles of darkness, 70 feet below the surface, where pilots would guide billion-dollar machines through the unknown, trusting instruments, fighting currents, racing against time. One error, and the Atlantic Ocean would win. To understand what makes this project so treacherous, you need to understand the Hampton Roads shipping channel. This isn't a calm river. It's a major artery for global commerce. Container ships, oil tankers, military vessels that dwarf city blocks. They pass overhead constantly, creating pressure waves, shifting sediments, stirring the seafloor into a churning soup of mud and debris. Now imagine drilling through that. The tunnel boring machines, called TBMs, are mechanical monsters. Circular cutting heads, 43 feet in diameter, studded with tungsten teeth. Behind them, a quarter-mile of hydraulic jacks, conveyor systems, and support structures. They work like this. The cutting head rotates, grinding through soil and rock. As it advances, massive jacks push the machine forward. Behind the cutter, curved concrete segments are installed to form the tunnel walls. The machine inches forward, and the process repeats again and again, 24 hours a day. But here's the catch. The pilots can't see anything. They're sealed inside the TBM, operating entirely by instruments, laser guidance systems, pressure sensors, gyroscopes calculating position down to the millimeter. One wrong move, drift too high, too low, too far left, and the machine could breach the seafloor, flood the tunnel, or collide with existing infrastructure. The pressure outside is immense. 70 feet of water, plus the weight of sediment above. The walls must hold back over 30 pounds per square inch. Even a small leak could cascade into catastrophic failure, and they're not drilling through solid rock. Hampton Roads sits on layers of clay, sand, and gravel, constantly shifting, constantly changing. Soft in some places, hard in others. The TBMs have to adjust in real time, reading the geology through vibrations and resistance. It's like flying blind through a mountain. Except the mountain is underwater, and it's trying to kill you. The project began with the islands. Before any tunnel could be drilled, the artificial islands at either end had to be expanded. These aren't just piles of rocks. They're precisely engineered structures designed to withstand hurricanes, ship collisions, and the relentless assault of the Atlantic. Thousands of tons of stone were barged in and carefully placed. Concrete walls were poured to create cofferdams, temporary barriers that hold back the ocean. Inside these protected zones, workers excavated down to bedrock, preparing the launch shafts where the TBMs would begin their journey. Then came the machines. Each TBM was assembled on site, piece by piece, lowered into the shaft like a beast descending into the underworld. The teams ran final checks, hydraulics, electrical systems, laser guidance. Everything had to be perfect. And then they started digging. The cutting head roared to life, teeth biting into earth. The machine lurched forward. Soil and slurry were sucked up through pipes, processed and disposed of. Behind the cutter, workers installed the concrete tunnel segments, curved panels that locked together like a giant jigsaw puzzle. Progress was measured in feet, not miles. On a good day, the TBM might advance 50 feet. On a bad day, when the geology turned treacherous or equipment failed, it could be nothing. Communication with the surface was constant. Engineers monitored every vibration, every pressure reading, every degree of deviation. The slightest anomaly could signal disaster. And disaster was always one mistake away. Tunnel boring is a ballet of controlled chaos. Too much pressure on the cutting head, and it could jam or break through into the shipping channel above. Too little, and the tunnel walls could collapse inward. The pilots had to maintain perfect balance, advancing the machine while keeping the pressure stable, the alignment precise, the crew safe. Weeks turned to months. The TBMs crawled through the darkness, carving their path beneath the waves. Above them, ships passed, oblivious to the engineers fighting the Atlantic just feet below their keels. And slowly, impossibly, the tunnels took shape. No project this ambitious goes according to plan. There were delays, equipment failures, unexpected geology that slowed progress. To a crawl, the TBMs encountered pockets of harder material that chewed through cutting teeth faster than anticipated. Replacements had to be ordered, shipped, installed. Each delay costing time and money. Then there was the risk of subsidence, the seafloor sinking as material was excavated below. Engineers had to constantly monitor the channel, watching for any sign that the ground above was shifting. Too much movement and ships could run aground. Or worse, the tunnel itself could be compromised. Weather added another layer of chaos. Hurricanes forced evacuations. Storm surges flooded work areas. Waves battered the islands, testing the strength of every barrier. And through it all, traffic kept flowing on the old bridge tunnel. Construction crews worked inches away from live traffic, coordinating schedules, managing closures, ensuring that no accident or delay stranded tens of thousands of commuters. The pressure was immense, not just from the ocean but from the public, the military, the government. Every day over budget was another day of gridlock, another day of vulnerability. But the teams pressed on, adjusting, adapting, solving problems no one had anticipated because failure wasn't an option. And then, after years of grinding through darkness, the moment arrived. The TBM broke through on the far side. The cutting head emerged from the earth, daylight flooding into the tunnel for the first time. Engineers erupted in celebration. The impossible had been done. They drilled beneath the Atlantic, beneath one of the busiest shipping channels on Earth, and emerged exactly where they'd planned. Millimeter-perfect accuracy, over 4 miles. Through shifting soil and crushing pressure, it was a triumph of human ingenuity, of precision engineering, of courage in the face of the unknown. But the work wasn't finished. The tunnels had to be outfitted. Ventilation systems, lighting, fire suppression, emergency exits, miles of electrical conduits, and plumbing. Every detail scrutinized, every system tested. The bridges were completed, the islands finalized, the roadways paved and striped. And finally, after years of construction, billions of dollars, and the efforts of thousands of workers, the new Hampton Roads Bridge-Tunnel was ready. Today, drivers crossing Hampton Roads might not think about what lies beneath them. The tunnels bored through darkness, the risks taken, the lives spent fighting the ocean. But it's there, 70 feet below the surface, a testament to what's possible when engineering meets determination. The commute is faster now, the gridlock eased. The naval base has the access it needs. But more than that, the project proved something fundamental, that no challenge is too great, no obstacle insurmountable. That human beings, when pushed to the edge, can move mountains, or in this case, move beneath oceans. The Hampton Roads Bridge-Tunnel. Expansion isn't just infrastructure, it's a declaration that we will not be stopped, not by geography, not by pressure, not by the crushing weight of the Atlantic itself. We drill through, we build, we endure, and the lights keep moving across the bridge, through the tunnel, into the future.